So, did you get the answer? Where is he? उज्जवल आया आंसर आया उसका? यार वहां पे तुम लोगों को पीछे बैठना चाहिए था, तो तुम बैठे नहीं। मैं किताब हाथ में लेके घूम रहा था, यहाँ पे दो टेबल छोड़ दी ऐसे। चलो, so any more numerical you want me to do, or shall we start the next chapter? Next chapter, ठीक है? We'll start. The next chapter is household circuits. Sure. Household circuits. So household circuits is about how the wiring is done inside our house. Okay. So that's inside, but what comes from outside? Okay. So there is somewhere the electrical energy is generated, right? So how much? So you have it is generated at 11 kilovolt. So there is power generating station. Right? At power generating station, how much it is generated at? 11 kilovolt. Now there is a reason for it, and we don't want to go into it. Right? In our house, what is this power? What is this volt that reaches our house? It is 220 volt. So domestic supply is 220 volt. So in between, now what happens is between our domestic or our house supply and from where it is generated, sometimes the distance could be hundreds and thousands of kilometers. You must have seen those huge poles, right? Poles named. Pole बोलेंगे उसको. That crisscross structure carrying six wires when you go on highway. Have you seen that? This kind of. You all give me such a puzzled look, no? Have you seen it?
Grid substation.
Yeah. So no, these are like transmission lines. Have you seen it?
Never.
Okay, so these are those wires, right? So from here to our domestic supply, in between they are carried like this, and then we have small poles like in old days, in old movies you will see, right? Or in some villages, then you have poles like this which carry wires on. So these are the main carrier transmission line. Then these are local distribution, and then from there these three wires will come to our house. What are those three wires? Light, neutral, and earth, which is also called ground. Okay. So when they are carried like this, they can't be carried at 11,000 volt. It's like 11,000 volt. Okay. We can produce more than this, but then that will lead to insulation issues because this will be so powerful that it will make the surrounding air conducting. So we don't generate more than 11 kilowatt. We can't generate less also because then it will be created at very high current. So this is the standard. When the power is generated, it is generated at 11 kilowatt. Now when it is transmitted at a higher voltage. It is transmitted at 132 kilovolt. Okay, why do we? So we step up. So we step up at what do you call? Substation, grid substation. Step up. So step up because from 11 to now 132, right? We step up to 132 kilovolt at what is called as grid substation. So production happens elsewhere. Now this is distribution or transmission. So this is through grid substation. It is stepped up. Stepping up is done through some step up transformer. So you understand that it is some kind of a device which is able to increase the voltage from 11 kV to 132 kV. Okay. Now it is given to these wires, right? On the other side, So let's say it has reached the town where this power was supposed to be distributed. Then what is it done? What is done over there? It is first stepped down. It is stepped down. Step single P, right? Is it double P or single P? Step down.
Double P.
Double P. Is it double P?
No, single P.
See?
So step
Down. Step single P, no?
No, sorry, then the step, then the double P.
Double P.
Okay, take only P, then it is step down.
Step down, yeah. Step.
So step down is the process. It is step down to 33 kilovolt. Achha. How? Go for it. Okay. So step down to 33 kilovolt, right? So 33 kilowatt supply is needed to power industries. Then it will be given to. So who does it? It is the main substation in the town where you need it, right? So it is done to by main. Who does the step down? By main substation. Substation. So this supply is given to heavy industries. Heavy industry. So heavy industries require 33 kilowatt. Right? Bharat Heavy Electricals Limited. You heard about it? These are very big. Larsen and Toubro, right? So these are big or Reliance Industries, okay? ONGC, those kind of things. So heavy industry. Then there is one more city substation, right? Is it city substation? Before that there is, you have intermediate substation, right? So further it is stepped down. What happened to the pen? It is stepped down further. Step down further to how much? 11 kilowatt. Same thing. And then this is given to not heavy industries like light industries. Light industries, right? What is it? Light, light industry in the sense offices. Okay? Light industries or small factories, right? Then the city substation to the domestic user. This is by intermediate substation. So substation is some facility where we can increase or decrease the voltage. So here we are stepping down, stepping up where it was produced. When it is distributed, then it is stepped down. Okay, now we step down further to 220 volt. Right? Who is that? Achha, let's speak up. Step down further to 220 volt, and it is done by city substation. Oof. Shrill. It's entering from small. So step down to 220 volt by city substation, and this is given for domestic use.
House.
Yes. Domestic use. Okay. So is this from production to distribution, right? So this is how it comes. Now household circuit will begin after this. So after this, these three wires you will get live, neutral, and earth. There is live, neutral, and earth. Okay, so these all three wires are everywhere. Okay, so what is live wire? So it carries the current, right? Carries current. Neutral wire is, so what is the circuit now? What kind of circuit we are familiar with? We are familiar with this, right? Okay, so there is a current in the circuit. So this you can call live. Then it has to also return to the source node. So this circuit has to be closed circuit. So when the current comes, it returns from neutral. So it is called return path. Right? So battery supplies current in this direction. And then it returns through this direction. So this is the second part, which is neutral. Okay?
So neutral is connected to the live wire.
Yeah. So there is like, let's say this was L. So till here it came, then goes through your house, then it returns. Then the circuit is completed. Got it? Got it? So you need a full circuit, right? So the three wires come from here also. Live, neutral and earth. So it goes and comes back throughout. Now neutral and earth are connected at the same point. So they are at zero potential. This is at higher potential, plus higher. So 11,000. How much? From 0, this wire is at 11,000. But when it reaches home, what is this difference? 220. In our home, this difference is only 220. Got it? Understood? So this is what it is. So now we have to study circuits this onwards. How the wiring is done after this. This is none of our business. That is taken care by big companies, right? And this, a local electrical contractor can also do it for us. Got it? Okay. So let's see now. So what is this? This is the first part we did was transmission of power from the generating station to the consumer. So power transmission from the generating station to the consumer. Okay, this is how it works. Now second topic is, you only need to know this, that whole thing, don't get, just remember the flow diagram, okay? So in the book, because there is no space, they have turned it. You can put everything straight also. Okay? Now the power distribution to a house. Now what do we do? So now look at this diagram in your book. Right? So these three wires first come to you. What is it? The live, neutral and earth. Okay. Then you don't take these wires directly. First you will have a company fuse. What do you have? It is called company fuse, right? So fuse is a safety device. It is called company fuse. And its rating is 50 ampere. So let us say now This earthing is shown as dotted, just to differentiate between. So it's not dotted or broken wire, it is a continuous wire. Okay? And these are having different colors so that you don't make a mistake in connection. Right? Colors will be learning later on. Okay? So let's say this one is a bigger, just to differentiate. Neutral is a, what is that? Put it on side. Right? After that, what do you have? So from where it is coming? This is coming from pole. This is coming from pole. This is coming from pole. Remember that pole? Now it is coming underground. So in villages you would see that some poles are there, but in our area, this is municipal area. So we get underground cable and it will have all these three wires. Pole or underground cable. So that will give us three connections. Underground cable. Clear? So now this is our society boundary or house boundary, whatever. Okay. Let's say it's a bungalow, just one house. So we have a company use. After that, what will we have here? Meter, which will show how much electricity we are consuming. So this is ground or earth. Okay. It will show all the watt meter. Okay. kWh unit. Right. So then it goes ahead. Okay. Now where will we take it? We will take a main switch. Okay. Energy meter के बाद में we will take a main switch. So main switch is the switch which will either power our house or shut it off completely. Let's say you want to do some modification. You want to switch it off. You don't want to work on live wire, right? So it is like double pole switch, like this. Okay. So this is a double pole switch. And the earth is connected to the body. So what is it? This is main switch. Is it main switch? Yes. Okay. So it's a double pole switch, right? Again, so this is just the safety mechanism for the. So right now, is it open or closed?
Closed.
Is it closed?
No, open.
Open. Both contacts are up. This wire has reached here. If it is closed, then only it will go ahead. Otherwise, no. Okay. So double pole means it's a double pole switch. Okay. Generally, in our house or in single circuit, we have seen connection only in one wire. But here, live as well as neutral are disconnected. So there is no possibility of getting a shock. Okay, sometimes what happens, if the neutral is connected and somehow there is a short circuit between it, then the current will run in the whole facility. That's why to be on the safer side, a double pole switch is used. Okay, so there is no live as well as no neutral connection added. So now these three things are taken into a distribution board now. So what is the distribution board? Distribution board is from where we can take the wires to different rooms, bathroom, kitchen, right? Like that. So let's say we have 3-bedroom hall apartment. Okay. So 3 BHK, then we have a kitchen, toilet, so on and so forth. So we need 5 connections. So 3 rooms, 2 bathrooms, then we have kitchen, then we have toilet. Let us say. ठीक है. So we restrict ourselves to these two. Or so how do we need now? There will be one. So in distribution, this wire is live. It jumps and goes here. So this is our neutral. Okay, and then we have earthing. So this is earthing, 3 wire. This is jumping means it is not connected, it is connected over here. Got it? Now what we will do, we will pull. This is live, this is neutral, this is earthing. So live, neutral, earthing for first row. Then those wires will go. Okay? But what we do now, here we connect one fuse. Now we have a main fuse. Okay? So for every room also we can have a fuse now. You might have heard about MCB now. Miniature circuit breaker or main fuse. So this fuse is of what rating? 30 ampere. Right? Let's say 30 ampere. And then you have neutral wire. This goes ahead. Got it? Similarly, you will take another connection. So this is what happens in the distribution board. Live, neutral. So you have live, neutral, earthing. Then a fuse for that room. So we are adding safety measure everywhere. Like that. It will be extended in another room. Likewise, you can have as many you can pull. So you can see the diagram now. Okay? So as many LEN you want, you can, LNE. LNE. Is it LEN or LN? अच्छा उसे अर्थिंग बीच में ले लिया वो ठीक है वो चलेगा उससे भी फर्क नहीं पड़ता LNE बाहर तक है अंदर जाके वो LN कर दिया उसे ठीक that's fine so it depends on the connection right so this is so wherever you want you can pull okay understood so we call this as a distribution board because now these 3 wires which came from outside they are now distributed to wherever I want to use it board. Is it understood? Okay, that's all it is. This is my distribution. So, 2 is lost. So, this is the household circuit till outside your room. Now, we'll go wiring inside the room. So, first you understand till here. Okay? So this is the power distribution till your house. Now we are entering in the house. यहाँ तक समझ आ गया? So you can just look at the diagram and try to just on the diagram itself you can write these notes so that you understand. Right? So here these two it only means is it is connected via meter then it is going. Okay? Then it's like this via meter. So in your book there is no connection shown here. What does it mean? It is connected, screwed here behind. Okay? So meter everywhere. Both the points are screwed to this wire. This is what you should understand. Okay? So it is screwed here and screwed here like that. Any questions so far? Take some time to read through it, the diagram.
What is the use of company fuse?
Company fuse means, suppose you want to fix a new meter, then what do? You have to cut the supply, no? Or let's say there is a fire broke out, okay, or you have connected so much load, right, which exceeds 50 ampere, and instead of catching fire there, it will just melt the fuse bar.
Yeah. Yes.
Okay, so it's a safety device, right? Like the whole society has some disaster. So what will you do? You will cut the power here.
So it will be an open circuit and the.
Yeah, so the whole compound is now without supply. You know, to carry out maintenance, repair, then you need to cut the main supply. So fuse is not like main switch. Main switch is anywhere there at the house level. You can have a main switch here also. Okay? But fuse is for that. Suppose somebody overdraws current more than approved rating, right? Then it will go. Like you have taken connection for light industry and you are running heavy industry. So this fuse will not allow you to do that. It will burn. So then you have to upgrade and subscribe to a higher heavy industry connection, 33 kilo, something like that. Okay, so it will keep you in check. So if you are a domestic user, it is decided you cannot have appliances whose total input current is more than 50 amp. Okay? Understood? What is the use of company? So it is the safety at a bigger level, and this is the safety at a room level or an appliance level also. Then when you use an appliance, every appliance has got its own fuse. So at a room level, then at an appliance level safety, every appliance also has its own internal fuse. Okay, because short circuit can take anywhere. So to save the appliance from burning, what happens is its fuse just blows off. Okay, so the appliance is safe. Okay, let's proceed further. So now how the wiring is done inside the house. So there is something called as ring system. Can I erase it? So this is a much better chapter without any numericals and a lot of work for teacher. It's like it will be a lot of work for you also when you write the answers. Okay, so do practice the diagrams. You will not get it otherwise. Okay, next is the house wiring system, right? Now, again, our starting point is these three wires, L, N, and E. So L, N, E has, right? This is coming from where? Tell me.
Distribution box.
Yes, distribution box or board it is. Box, correct. Did I write board there?
No, box.
मैंने box लिखा था? Okay, so distribution box. Board भी चलेगा, it's okay. Distribution box होगा तो covered है, board मतलब खुला है. ठीक है? So from distribution box. So all three diagrams are connected, right? So we are seeing them in parts. Now inside the room, what do we do? So what is the title? Power distribution, house wiring. So it's a ring system. House wiring. That is, we are learning ring system. Ring system. So ring system में क्या है? अभी ये 4 walls है, तो we will make a ring. ठीक है? 4 walls में हमने वो वायर का ring बना. Then we have made जो बीच वाला वायर है वो बड़ा बनाएंगे. ठीक है, so this is another ring, then we have another ring. ठीक, so this is our neutral. न्यूट्रल हो गया, ये अर्थ हो गया। ठीक है, अब ये लाइव है तो हमने लाइव को यहाँ पे लाके ज्वाइन कर दिया। अब ये हमारा लाइव रिंग हो गया, ये हमारा न्यूट्रल हो गया, ये हमारा अर्थ हो गया। ठीक है, अब हमको हर दीवार पे अप्लायंस लगाना है। ठीक है, अगर मुझे ये वॉल पे लगाना है तो मैं इसमें से 3 कनेक्शन ले लूंगा। मेरे को क्या चाहिए, लाइव और क्या चाहिए, न्यूट्रल। अर्थ चाहिए कि नहीं वो डिपेंड करेगा वेदर आई एम टचिंग दैट अप्लायंस और नॉट। लाइक माय फैन, आई डोंट नीड अर्थिंग फॉर इट, क्योंकि मैं तो उसको टच करूंगा नहीं तो मुझे शॉक नहीं लगेगा, है ना। तो लाइव में नाउ आई विल गिव अ सेफ्टी फ्यूज। ठीक है, दिस इज माय लाइव कनेक्शन। अब ये क्या करेगा, ये जाएगा मेरा रेगुलेटर में, है ना। तो यहां से ये चला जाएगा किधर, फैन। ठीक है, ये मेरा फैन है। अब ये रिटर्न होना चाहिए। क्या गड़बड़ हो गया इसके अंदर, स्विच नहीं दिया, चालू कैसे हो। तो इसमें हमको क्या चाहिए, एक स्विच भी चाहिए। तो पहले फ्यूज और उसके बाद एक स्विच। ठीक है, तो ऐसे करके हमें जितने चाहिए हम डिवाइसेस लगा सकते हैं। ठीक है, ये स्विच के बाजू में तुम एक इसको सर्कल करो, समझ आ गया। तो जहां से चाहिए वहां ऐसा खींचो होगा। देखो डायग्राम में वही किया है, 2-3 क्या क्या डिवाइस लगाया है, लैंप लगाया है, फिर एक सॉकेट लगाया है। तो सॉकेट में हमको अर्थिंग चाहिए, लेट्स से वी नीड अ सॉकेट। तो सॉकेट कैसा होता है, सॉकेट में 3 पिन होता है। ये देखो इसमें 3 है, आप लेफ्ट राइट, है ना। यस, भाई वो भी सेफ्टी डिवाइस है, बताता हूँ आपको।
It will take those extra current.
हाँ, तो ये तुम्हारा जो पिन है, ठीक है, ये अर्थ में आके लगेगा। ठीक है, ये कनेक्ट हो गया तुम्हारा सॉकेट के अर्थ में। ठीक है, ये तुम्हारा लाइव है, समझो ये लाइव आ गया, है ना। तो ये पिन में स्क्रू कर दिया और ये क्या हो गया तुम्हारा, न्यूट्रल। ये ठीक है। अब इसके पहले हर लाइव में हम क्या देते हैं, फ्यूज। फ्यूज दे दो और एक स्विच दे दो। हो गया, ठीक है ना। तो अभी इसमें हमने अर्थिंग क्यों दिया है, अर्थिंग क्या होता है, जैसे इलेक्ट्रिक आयरन, उसका समझो बॉडी मेटेलिक है। ठीक है, अभी ये जो लाइव वायर है, ठीक है, और ये जो न्यूट्रल वायर है, ये टच हो गया कहीं पे गलती से। बिकॉज हमारे जो वायर होते हैं उसमें 3 वायर होते हैं, तीनों साथ साथ जाते हैं, है ना। अर्थिंग, लाइव और न्यूट्रल। कभी वियर एंड टियर या मुड़ते मुड़ते क्या होता है, लाइव और न्यूट्रल का इंसुलेशन ब्रेक हो जाता है, तो आपस में टच हो गया। ठीक है, या फिर ये और ये टच हो गया, ये और ये टच हो गया, फिर तो शॉर्ट सर्किट हो गया, ये दोनों टच हो गया आपस में। ठीक है, तो अब क्या हो गया, जो करंट है लाइफ का, वो किसमें आ गया? अप्लायंस के बॉडी में आ गया, और वो गलती से तुमसे टच हो गई, तुमको शॉक लगेगा। तो तुमको शॉक नहीं लगने से हमने क्या कर दिया है, उसको अर्थिंग में डाल दिया। अर्थिंग में क्या हुआ, वो मेरा बॉडी रेजिस्टेंस अर्थ के रेजिस्टेंस से ज्यादा है, so the current will not flow through the body, it will directly go to earth, even though the current is available in the body of the appliance, but it will always try to flow through the path where resistance is less. So earth is always like grounded. There is, वो क्या करेगा, वो उसमें से आके फट से यहाँ से होके ग्राउंड में जाएगा, it will not affect us. So fuse and earth, these two are safety mechanism. Fuse will save you from fire and earthing will save you from fatal shock. In case your device body was touching the live connection somewhere. भाई ये किसी को नहीं समझ आया तो फिर पूछ सकता है, don't give me a zombie loop. किसी को नहीं समझ आया? अर्थ वाला शॉक लगा, कितने लोगों को शॉक लगा घर में? तुमको सेंटर शॉक खाना चाहिए। I'm asking you कुछ, I mean, is it clear to you? Boys, ठीक है, घर में उंगली मत डालना जाके, ठीक है? Just to experience shock, right? Okay, anything else? So this is all about house wiring, ठीक है?
So,
yes.
How does short circuit happen?
When light touches neutral.
But we have the earth wire in between.
No, live and neutral is like, shorted. It's like without any load. So then there will be heat produced. Lot of energy discharge is taking place. Spark will be there. That's why we have load in between. No, we have load in between. Between live and neutral there is a load. You see?
But if it
See, this is now if it touch, so there is no load. So what happens? I is equal to V by R. So it is V by 0. No load means zero resistance. So current will be infinite. Infinite current means how much heat? Okay. So square of current. Huge current means heat, fire.
So we don't have any preventive measures for that.
Fuse. That's when as the current increases, it will melt.
So they won't touch.
They will touch, but there is no current ahead of this. So your house is safe. Okay? Now understand? So there are two times when this fuse blows off. One is when the live is touching the neutral. Like when live is touching here, when the live is touching neutral, there is a short circuit. Second is, in this connection only, you added so many connections. So everybody is now pulling current from the same source. Let's say you were supposed to connect only one fan, but now you put a spike guard, 5 extension. Now 5 fan लगा दिया, यहाँ पे एक लगा दिया, फिर एक हीटर भी लगा दिया। सैंडविच बनाना था स्टडी टेबल के बाजू में, केटली भी रख ली चाय की, ठीक है? तो एक चाय की भी केटली रख ली और एक गरम, जो तो बहुत सारे तुमने कनेक्शन ले लिए। फिर तुमको डांस करने का मन किया, हाई वोल्टेज एम्पलीफायर लगा दिया। अब क्या हो गया? यहाँ से करंट जाना चाहिए था 30 एम्पियर के नीचे और जा रहा है 50, ठीक है? तो थोड़ी देर हैंडल करेगा, बाद में जल जाएगा। तो जलने से बचने के लिए क्या होगा? सडनली सब कुछ बंद हो जाएगा क्योंकि मेल्ट हो गया, ठीक है? सो फ्यूज वायर किस चीज का बना होता है? फ्यूज वायर
हाई मेल्टिंग पॉइंट,
लो मेल्टिंग पॉइंट,
लो मेल्टिंग पॉइंट, सर लो मेल्टिंग पॉइंट।
फ्यूज वायर हैज लो मेल्टिंग पॉइंट, ठीक है? तो इट इज मेड अप ऑफ एलॉय ऑफ लेड एंड टिन, ठीक है? कंडक्टिंग वायर क्या होता है? कॉपर। It has a high melting point. Its melting point is upwards of 1000 degrees Celsius. Its melting point is 250 degrees Celsius. So if you wait till 1000 degrees Celsius, the whole house will be on fire. So if you don't have this fuse, gone, because वो तो current लेता जाएगा ज़्यादा लेकिन melt नहीं होगा. Suddenly there is so much heat. If the wooden ignition temperature is crossed, then we'll have fire, and it will keep like giving that. ठीक है? That's why short circuit में. So this is when you have this thing, then it is called overloading. This is called overloading, and this is called short circuit. These days, a lot of news is coming of building catching fire, hospitals catching fire, because the staff is unaware, and they just go on adding like all the appliances. So overloading, and there's no safety mechanism. Here, safety at so many levels. This is at appliance level. Then we saw there was a safety at distribution level. Before that, there was a safety by company switch. So 3-layered, multi-layered safety. But people like in rural area or those who have started using electricity recently, so they are not. उनको तो electricity पहली बार आई है, safety तो फिर बाद में देखेगा ना आदमी. तो लगाते जाते हैं appliance फिर boom, ट्रांसफार्मर जल गया. सुना है ना गांव में, इसलिए हो रहा. Yes. हाँ.
So रेड कलर का बॉक्स है क्या ना इलेक्ट्रिसिटी के वो क्या डिस्ट्रीब्यूशन बॉक्स है.
कहाँ पे कैसा?
जो बिल्डिंग के बाहर में रेड कलर का.
हाँ वो मतलब सोसाइटी लेवल पे डिस्ट्रीब्यूशन है. वहां से 3 LNE निकलेगा अलग अलग सोसाइटी में जाएंगे. हर जगह पे डिस्ट्रीब्यूशन बॉक्स है और कंट्रोल पैनल है. मान लो 2-3 सोसाइटी ने बिल नहीं भरा, लिफ्ट चला रहे हैं, वाटर पंप चला रहे हैं, बिल भर नहीं रहे, तो सिर्फ क्या करेगा, तुम्हारी सोसाइटी की बत्ती गुल. बाजू वाले सोसाइटी की नहीं, सिर्फ तुम्हारी, क्योंकि तुमने बिल नहीं भरा. That's how they control ना. भाई तुमने बिल नहीं भरा तो तुम्हारी बिजली कट की तो दूसरे वाले को क्यों तकलीफ होनी चाहिए, इसलिए वो डिस्ट्रीब्यूशन हर लेवल पे है. ठीक है. So it's that's how it is. तो अब देखो what is the benefit of this, advantages of ring system. How much more time we have? So I want you to read 1, 2, 3, 4 points, right? That will tell you what is the advantage. Now you should. So have you understood everything what I have explained in this at least? Now read the advantages. So I want one person to read it so that everybody else can read. Boys, do you have book? Or shall we have a more audible voice from girls' side? Go ahead. Advantages of the ring system. Sit and read.
Advantages of the ring system. The ring system has the following 4 advantages. In the ring system, the current from mains can reach to an individual appliance through 2 separate paths.
Yeah, hang on. So what are the 2 separate paths? Now see, it can reach current from here also or from here also. So if something goes wrong, then at least you have a backup. So 2 paths. Every appliance gets 2 paths. Okay, next.
Thus, each appliance gets connected to the mains effectively through a connecting wire. Therefore, the wire required for the main ring is of a lower current carrying capacity than that which would be required for a direct connection to the mains.
Right. So it's like length is same, but the cross-sectional area has increased. So effectively, the resistance has reduced. So with the low current capacity wire also, you'll be able to power the appliance. Got it? Understand? Area of cross section, like एक का thickness दूसरे का thickness जुड़ गया. Take it, look at it that way. Got it? Yeah.
This reduces the cost of wiring considerably. Second, each appliance has a separate fuse. Therefore,
why it reduces cost of wiring? Because you are able to manage it with thinner wire. Okay? Thinner wire say you are able to get the benefit of thicker wire because of the ring architecture. Okay, go ahead.
Each appliance has a separate fuse. Therefore, if due to some fault the fuse of one appliance burns, it does not affect the operation of the other appliances. Third, in the system, all the plugs and sockets used can be of same size, but each socket should have its own fuse of rating suitable for the appliances to be connected there.
Right. So it gives you flexibility at an appliance level, right? And any corner of the room you can pull connection, right? You don't have to lay cable till the distribution box. So this ring system is very efficient way of doing house wiring. Okay. Next.
Fourth, while installing a new appliance in a room, a new line up to the distribution box is not required.
This is what I say.
But it can be directly connected to a ring circuit in that room. The care is taken that the total current drawn from the mains in the ring circuit does not exceed the rating of the main fuse.
Alright? Okay. Now, the connection of all appliances like bulb, fan, socket, etc. with the mains. Read that. Read.
We note that all the electrical appliances, say bulbs, fan, socket, etc., are connected in parallel with the mains. In the live wire before each appliance, a separate switch and a separate fuse is connected in series with them.
Right. So, are all the appliances connected in parallel? See, everything is in parallel only, no? So each is getting full potential difference, right? This is also getting full potential difference. This also is getting full potential. But it's not in series. So what is the benefit of parallel connection? If this appliance goes bad, this continues to work, no? As long as my ring is receiving the alignment. Okay? So parallel connection is good. Like if there is a fault happening in one area, it is isolated, right? It doesn't affect working of the other appliances. Yes. So 1 second. In the live wire before each appliance, there is a separate switch and a separate fuse connected in the series. So this is I have already explained. Now, what is the advantages of connecting appliances in parallel and what is the disadvantages of connecting appliances in series? Okay, this is important. This is asked. So read that and see if you have any difficulty in understanding. So what are the advantages? There are two advantages. So each device gets its full potential difference in parallel, right? So in series, what happens? Potential difference is divided. V is equal to V1 plus V2 plus V3. But in parallel, V remains same. Potential difference remains same, right? What is the second thing? Each appliance operates independently without being affected whether the other appliances are operated or not. So I already repeated. Okay. Now read the disadvantages of connecting appliances in series. Read it.
Different appliances are not connected in series to the mains for the following three reasons. First, the voltage on the source gets divided in all the appliances connected in series in ratio of the resistances, so each appliance does not operate at its rated voltage. Right. So every device will not get 220 volt. It is getting divided amongst various appliances connected in series. Because in your house, what is the maximum potential difference? 220 volt. Okay. Next. Second, on connecting one or more appliances in the same circuit, the resistance of the circuit will increase. Hence, it will reduce the current in the circuit, so each appliance will get less power.
Yeah. You understand? When the appliances are connected in series, so in series, what happens to the resistance? They get added. So if the resistance is more, the current flowing will be less. So the appliance will not be able to work at its full capability. Because it is not able to get full power. Power is V times I. Okay? So that is another disadvantage. Last.
Third, all appliances connected in series operate simultaneously. None of the appliances can be operated independently. If one appliance is switched off or not operated, no other appliance connected with it in series will then operate. Right.
So imagine a condition where you need a dim light, but you can't do it. Either you operate with all the bulbs on in your house, or it is a pitch dark situation. So you don't have flexibility. So in series, either you switch on. Huh? Why? How come? Like अगर तुमको थोड़ा लाइट रिड्यूस करना है, तो एक लाइट नहीं जला सकते सीरीज में, या तो सारे जलाने पड़ेंगे, या एक भी नहीं जलेगा. पैरेलल में वो फ्लेक्सिबिलिटी है. You can decide, ना? नहीं. Parallel में you have the flexibility of control at a individual appliance level. Series में you to series में current is same. अगर एक appliance बंद कर दिया तो current आगे नहीं जाएगा, सारे बंद हो जाएंगे. ठीक है? So is it clear now? How much more time we have? 5 minutes, huh? Okay. तो ठीक है. तो ये अभी with this we have completed unit 1. Then we have
So
unit
then,
2.
where do we have series connection?
Good question. So are we not having series connection here? This is series connection.
Okay, so fuse,
Yeah.
switch, and
Right.
plug.
Yes. Or suppose in your building designing some circuit, you already invested in a small resistor, but now you thought, okay, that is not doing the job. I want to increase the resistance. Add one more resistance.
So that will be in series.
If you want to reduce the resistance, you add one resistance in parallel. So it depends on the design. Anything is possible. It's just about whether it is a good design or a bad design. It will work. So the thought is required at the designing and planning level. When you are doing a new house or anything, that's when you have to think. Okay? And if you can't think, hire an expert. Okay? There is an expert available, so don't do this specialized task yourself. But you should know why are we studying, reading or learning this, so that we understand what the expert is doing. Because we know what our needs are, so we will tell. देखो 4 लाइन यहाँ पे चाहिए, 2 यहाँ पे चाहिए, खींच बाहर तेरे को जैसे खींच. But at least we should know ना what do we want for that. ठीक है? Okay. So just go through the paper and pages, and if you see if you have any doubt, ask me. Read the examples given. These are good illustrations. Just see if it makes sense to you. बुक ही नहीं लाया तुम लोग यार. एक बुक दे दो बच्चों लोग. एक दे दो तुम अपने बुक इधर दे दो. तुम इनके साथ ज्वाइन हो जाओ. चलो पहला वाला क्या फिगर 9.5 है क्या है? How will you connect a bulb and a socket in room to mains? Draw a labeled diagram in support of your answer. तो कैसे किया है? Bulb पे do you require earthing?
No.
Because you don't touch the bulb, right? So just a live and neutral will do. So the connection shown to bulb is only to live and neutral, and you have a fuse and a switch to operate the bulb, right? Then what about the socket? Socket we generally give earthing also.
Earth wire is required.
In the center, yes. Earth is in the center. One is live, one is neutral. So switch is always connected to switch, and fuse is always connected to live. First fuse and then switch. Okay, this is the sequence. Where is fuse? Closer to the live. Then switch after fuse. So there has to be safety first. How will you remember? Safety first, operation later. Okay? Fuse first, switch later. Next diagram, what does it tell you? Diagram in figure 9.6 shows a battery, a switch and 2 bulbs, right? Complete the diagram to show the electric connections of the bulbs to the battery. So, and how have you joined the bulbs in part A? Give read. So there are 2 bulbs, and now you have to connect it like so. What is advisable, a series connection or a parallel? Parallel.
So that if one goes up, the other one will
Continue to function. Okay. So what we have done, 2 wires have been drawn, and the bulb is connected with both the wires. Got it? So the diagram itself is given, right? So what is the description? The 2 bulbs are connected in parallel region. Both bulbs glow at the same voltage. Okay. So one bulb. So now you don't have a choice. Switch एक ही है. So both the bulb will blow at the same time. There is only one switch ना. Given क्या था तुम्हारे पास? एक battery, एक switch, and both the bulbs. So the only way possible is you can connect it when both the bulbs are glowing together. Okay? So this kind of questions might be asked. Okay? So read it and if you have any doubts in the next class. All right. See you in the next lecture.